Hello everyone, today let's learn about the composition of diesel fuel together. Diesel is composed of 87% carbon, 12.6% hydrogen, and 0.4% oxygen. Formula T, yellow liquid, hydrocarbon. The carbon atoms in diesel typically range from about 10 to 22. It is used as fuel for compression ignition engines, also known as diesel engines. Everyone is quite familiar with diesel. Let's take a look at how diesel is classified. Diesel is divided into two main categories, light diesel and heavy diesel. Among the performance characteristics of diesel, the most important are ignitability and fluidity. Their technical indicators are the cetane number and the pour point respectively. According to China's current diesel specifications, the sulfur content is required to be controlled between 0.5% and 1.5%. Diesel is graded based on its pour point light. Diesel has 5 grades: 50, -10, -20, -35, and -50. Heavy diesel has 3 grades: 10, 20, and 30. Light diesel is used in high-speed diesel engines with speeds above 1,000 revolutions per minute. Heavy diesel is used in medium and low-speed diesel engines with speeds below 1,000 revolutions per minute. The selection of diesel is based on the operating temperature. When the temperature is above 4 degrees Celsius, no zero diesel should be used. When the temperature is between 4 degrees Celsius and -5 degrees Celsius, no -10 diesel should be used. When the temperature is between -5 degrees Celsius and -14 degrees Celsius, no -20 diesel should be used. When the temperature is between -14 degrees Celsius and -29 degrees Celsius, no -35 diesel should be used. If the selected diesel grade is higher than the corresponding temperature for the conditions, the fuel system in the engine may experience wax precipitation, clogging the fuel lines and affecting the normal operation of the engine. Let's take a look at the composition of diesel. Diesel is mainly composed of alkenes, cycloalkanes, aromatic hydrocarbons, polycyclic aromatic hydrocarbons, and small amounts of sulfur, nitrogen, and additives. In terms of its basic chemical composition, the mass fraction of carbon is 87%. The mass fraction of hydrogen is 12.6%, and the mass fraction of oxygen is 0.4%. The performance indicators of diesel mainly involve 5 aspects. The ignitability of diesel refers to its spontaneous combustion capability. Diesel engines rely on diesel injected into the cylinder, coming into contact with compressed high-temperature air to ignite spontaneously. Therefore, diesel must have good ignitability. During diesel engine operation, after diesel is injected into the combustion chamber by the injector, it does not ignite immediately. Instead, it goes through a period of preparation before combustion. The time taken for this preparation process is called the ignition delay period. If the ignition delay period is too long, then a larger amount of diesel may accumulate before combustion begins in the combustion chamber. This can cause the pressure in the cylinder to rise too rapidly. Once combustion starts, subjecting the crankshaft and connecting rod mechanism to greater impact forces and accelerating wear. At the same time, slight knocking sounds occur in the cylinder and the engine runs roughly. Diesel, with good ignitability, due to its strong spontaneous combustion capability, requires a shorter preparation time. This results in smoother engine operation and allows ignition at lower temperatures, which is beneficial for starting. The ignitability of diesel is evaluated by the cetane number. Similar to the octane number for gasoline, it is also derived by comparing two reference substances with significantly different ignition properties. The numerical value is obtained by comparison. One is N-hexadecane, which has good ignition properties and is assigned a cetane number of 100. The other is alpha-methylnaphthalene, which has poor ignition properties and is assigned a cetane number of 0. By mixing them in different proportions, standard fuels with cetane numbers ranging from 0 to 100 can be obtained. The volatility of diesel refers to its ability to transform from a liquid to a gaseous state. Good volatility of diesel is beneficial for mixture formation, especially for high-speed diesel engines, since the mixture formation time is short. Good volatility is even more necessary to ensure rapid vaporization and mixture formation. This can shorten the ignition delay period. The volatility of diesel is indicated by metrics such as distillation range and flash point. The viscosity of diesel is an indicator of its thickness. Viscosity changes with temperature. When the temperature is high, the fuel becomes thinner and viscosity decreases. When the temperature is low, the fuel becomes thicker and viscosity increases. The viscosity of light diesel refers to its viscosity at 20 degrees Celsius. The viscosity of diesel affects its fluidity, atomization, combustibility, and lubricity. If the viscosity is too high, the fluidity is poor, affecting the fuel supply. Diesel with higher viscosity injected into the cylinder affects atomization, making it difficult to mix evenly with air. This leads to incomplete combustion and increased fuel consumption. However, the viscosity cannot be too low either. If the viscosity is too low during injection, the fuel droplets are too fine, and the spray penetration is too short, also preventing uniform distribution. This results in incomplete combustion and black smoke from the exhaust. Additionally, diesel with too low viscosity cannot ensure proper lubrication of the high-pressure fuel pump and injector, increasing wear. It may also leak from the non-sealing parts of the high-pressure fuel pump and injector, reducing the amount of fuel injected into the combustion chamber, thereby lowering engine power. The low-temperature fluidity of diesel affects whether it can be reliably supplied and whether the engine can operate normally. Metrics for evaluating the low-temperature fluidity of diesel include pour point, cloud point, and cold filter plugging point. The stability of diesel refers to its ability during transportation, storage, and use to maintain appearance, color composition, and performance. Metrics for evaluating diesel stability include total insoluble matter after accelerated oxidation, carbon residue of 10%, distillation residue, and actual gum content. In 2020, China's diesel production exceeded 170 million tons, and gasoline production reached 130 million tons, ensuring the country's fuel supply. Trends in the refining industry. First, the refining industry will move toward larger scale. Second, the development of refinery, petrochemical integration will improve deep processing capabilities. General Secretary Xi Jinping once said, "China has confidence in following its own path. Take care of your own affairs. Let's master professional skills, engage in national development, show self-worth." Okay, that is all for today's class. Goodbye.